Barakatuh. Hello, holiday makers. We are going through this discussion. So it is from item 5. We are going to look about organic chemistry. That is item 5, and this is how it goes. Use of nail polish removers and polymers is increasing in Uganda. A chemical plant makes polyethylene and ethyl acetate, a nail polish remover from propene and methane, respectively. As a way of mitigation, excess raw propene is treated with bromine water, while excess methane is reacted with chlorine gas in UV light. The plant management is interested in the stability of its products of their applications, analysis of its mitigations, reactions with the equations, and evaluation of its synthetic pathways and the possible implications of its products. Your chemistry teacher came across this information. Task: as a student of chemistry, make a write-up to address the plant management concerns. So before we attempt our scenario, you have to first highlight on the required information, because not all the information given will be important to us, but we shall look for those that are essential to us, such that we can make correct responses. If I can summarize the information given here, they are saying a chemical plant makes polyethylene, that is polyethylene and ethyl acetate. A chemical plant makes polyethylene and ethyl acetate and nail polish remover from propene and methane. So that is the first points that we can highlight from this item, respectively. It means that polyethylene is got from propane and ethyl acetate is obtained from methane, in other words. So now they are trying to tell us that indirectly they want us to show the synthesis of these compounds from this their respective compounds given. For example, they are telling us how can we get propene from how can we get polyethylene from propane. So starting with that item, let us first answer this first part. How we can obtain polyethylene. Polyethylene, it is a polymer. It is used in our daily life. So now they are telling us how can it be obtained from propene. That is an alkene with a double bond. So we are going to get polyethylene from propene. So polyethylene from propene, this is how you can obtain it. There are different pathways you can obtain a product. So it is according to the shortest one, because now this is a plant that requires simple processes to obtain their main product. So you have to use short rules such that you get to the product required. So propene, it's a double bond, carbon to carbon double bond. So we want to take to this polymer. Now this polymer, if you studied very well polymers, this polymer cannot propene cannot give us directly pro polyethylene, but it can be obtained from ethene. So it means that you have to reduce this number of carbons. You're seeing that you're having 3 carbon atoms. So it means that you have to reduce these carbon atoms such that we go to ethene. So to reduce these carbon atoms, someone can use, now for example me, I'll go what is made by ozonolysis. Ozonolysis, it will help me break this, split this propene given to me such that I obtain a product which is relative to ethane. So that is by addition of ozonide. Ozonide in the presence of carbon tetrachloride at a temperature less than 20 degrees. Then this one will help to break this compound. If I add what we call the zinc and the methanoic acid, with all these compounds added, reagents, they can help to split this one such that I form 2 products, but my interest is in only 1 product. So I'll go with that one. I'll form, sorry, this is a 3. I'll form a carbonyl compound, which is in that form. It is called ethanol. Ethanol, still I don't want ethanol. I want ethene with a double bond. So it means I have to also make ethene let me write it that. So ethanol is there. So still I don't want this. Let me also reduce this one by a process called dehydration. I'm removing this water molecule, that is by addition of sulfuric acid at a temperature of 180 degrees or 170 degrees. I will obtain my ethene. So my ethene, from this I can now obtain polyethylene. Polyethylene, it is a polymer. It is got from addition of many monomers. Sorry. So it means I can obtain polyethylene if I get many of ethene. So in other words, to obtain my polyethylene, I will add what we call the oxygen initiator. At higher temperatures and higher pressure. With that, I will yield my polyethylene. It is a polymer, so I can write it like this. And this is my polyethylene. So that is the path where they wanted us to obtain, to show them how we can obtain that polyethylene. So you can see the short roots that are not many, but they are obtaining we are obtaining our product that is required. So this also helps to for the company not to consume a lot, because there are simple ways to go through such that to obtain the product. Now, from this, they also told us that ethyl acetate can be obtained from methane. It seems not to be possible, but in other words, it is possible, and we can also obtain that ethyl acetate from, I think we have seen this one. We have seen how we have obtained our ethyl polyethylene. So we are going to obtain our ethyl acetate. Now, ethyl acetate is simply the ethyl ethanoate. Ethyl, many of you may be knowing your chemistry, but if you cannot interpret this one, you may fail the question. This is simply called ethyl ethanoate. Ethanoate, sorry. So ethanoate, and it is an ester. So we shall obtain our ethanoate or ethyl acetate from methane. Methane, it is an alkane, whereby some alkanes are not reactive enough. They do not easily react. So they want us to obtain that compound there from methane. Methane is there, so I will simply add. I can add anything such that I can make this one reactive, because I cannot form ethyl acetate from directly from methane. So it means I have to go through different ways. I can add. I want to make this one an alkyl halide. An alkyl halide meaning that an halogen, it is attached to the an alkane, such that I can go through. So I can add disulfide dioxide dichloride in presence of a dibenzyl at 60 degrees. With this, I will form this compound there. That is called chloromethane. So chloromethane, remember I want to form this one. This one can easily be got from a process called esterification. That is when I add an alcohol in presence of I can add an alcohol with ethanoic any acid or methanol, carboxylic acid, such that I can use that it can take place in a acidified medium. So it means from this I have to use an alcohol such that I can obtain an alcohol and I add there a carboxylic acid. So from this, I want to use an alcohol, so I can simply do. Can I do a substitution? Someone can use a substitution of sodium. You just heat. So if you heat that compound, it will yield that. That is can that work? Because we need an alcohol. So let us first look at the structure, the chemical structure of ethyl ethanoate. Ethyl ethanoate is like this. So this is the ethanoate. then this is the ether. That means in the mechanism, it is the we have the ethanoic acid. This is from the ethanoic acid. Then there is alcohol, one alcohol here. So it means that this we need an ethanol. So we need ethanol to obtain that. So let us first repeat our process. That is by adding a dibenzyl at 60 degrees. I said here we shall use chloromethane. So from this, remember I have to increase the the bonds such that we can obtain two bonds of that. So simply let us see what you can add so that you can obtain. If I add an alcohol, if I do substitution, I will yield that is methane, which is not our aim. So let us see if I can add the substitution. Let me see. That is a chloromethane. Chloromethane now to yield what is ethan. Ethan. So I have to yield ethanol. Then from ethanol we shall add to that is will be directly that is a methanoic acid. Methanoic acid in acidified medium, then we obtain the ethyl acetate. Then ethyl acetate, let me see. If I form an alcohol, I have to make sure that I increase these carbon atoms. To increase these carbon atoms, I can do, yeah, let me take it to an alcohol. Let me take it to an alcohol, that is by addition of sodium, and I heat, that is boiling. So I'll form this methanol. Methanol, it is not our interest, so we shall do some addition. So let us get this is ethanol. This is methanol. I can oxidize this one to form a carboxylic acid. If I add excess manganese oxide and I do heat, I will form that is ethanoic acid. Ethanoic acid, this one it is simple because now we have only got this. So we said it is called esterification. Esterification deals with the addition of an ethanoic acid, for example, and let me say an ethanol to obtain an ester. So I can add here. Let me try to add. Let me add it with ethanol. Ethanol that happens under heat, and it is a reversible reaction. And it is in a acidified medium. I can put ethanoic acid. Ethanoic acid or in a acidified medium, the proton means acidified. So this I will yield this compound that is required. Then the ethanoate, yeah, sorry, it's this one. So then this the two. So simply that was what was required from us to obtain ethyl acetate or ethyl ethanoate from methane. So this was simply the next part of the question. That was the key point that was obtained from that. They're saying as a way of mitigation. As a way of mitigation, I think I can wrap up this. So, as a way of mitigation, excess propene is reacted with bromine water, while excess methane is reacted with chlorine gas in UV light. Key points to note: as a way of mitigation, so that telling us that excess propene, excess propene is reacted with bromine water. Bromine water, then excess methane is reacted with chlorine, that's chlorine gas in UV. So that's how I can summarize that the required information. Now they're not they just told us to analyze to help to address the plant management concerns. So they are indirectly telling us to on the excess propane that is left from forming the products that we saw already, then methane they they mitigate them by reacting them with the propene, reacting it with the bromine water, and the chlorine with the uh no methane and with the chlorine gas in UV light. So indirectly they're telling us to show how they can react to the mechanism. Yeah, that's all. Because now if the propene is reacted with bromine water, it may be not dangerous as it could be propene alone. So it means that you have to show how this propene propene to react with bromine water. So bromine, that's a bromine water. So we have to obtain a product. That product is obtained as a mitigate. Then let us show how we can obtain that from the mechanism. So we are having our methane, no, propene, then bromine will split to give us a partial positive and bromine a partial negative. So this one, it is a nucleophile. It is electron rich than this one. So this double bond, they will attack that electrophile such that this so remember we should not form a carbonium ion such that we can protect our reaction. So it means that we should add our bromine to the carbon that is not making gas to form a carbonium ion, which is an reactive. So let me add it here. Then I'll plus, because now the bonds on this carbon atom, they are less than those that should be. So then this bromine pairs, so it will come and attack the carbon that is having less bonds, so such that this form a compound of this nature with our bromide attached there. Then the water. So since the bonds on the oxygen are too many, you can indicate that by a plus. And here, since there are many, there must be a proton reduction such that we stabilize our compound, such that this compound oxygen has the enough bonds. That is by reduction of a proton, such that we form compound this format. So if I've obtained that, so someone can give it a name. I can name it, that is a nomenclature of compounds. This is we are counting. This one is a 1. The bromo is attached to carbon number 1. Then the whole compound, it is 1, 2, 3. That is a propane. But now it is having this functional group, which is the hydroxyl group. So that is a propan.
Era enamba yagimanyi eyingira
nejafulumya. Carbon number 2.
Ayina ebitonde biri mu mazzi.
So it is 1 bromo, propan 2 all. Then from there, this hydrogen that is left out, that is gone under reduction with this bromide, they go under catenate the hydrogen plus this bromide, such that we form hydrogen bromide. So simply that was our mechanism. So I can simply write the product here. Which is our 1 bromo butane. So I have to make sure that the bonds are enough to every carbon atom that is in the molecule. I think that is our mechanism. So let us go to the next part. That's where they said excess. Now they said excess propene. Here they are saying excess methane react with chlorine gas to form a certain product as a mitigate. As a mitigation, so I can rub off this. This was 1. Then the next part, they want us to obtain. They are saying excess methane and reacts with chlorine gas. That is a UV light. Presence of UV light. So we have to get some product. Now, since they said excess, it means we shall form one product of chlorine. So, because now we know chlorination, this is a chlorination process. Chlorination, if chlorine is in excess, we obtain more of the compound. This is 1-chloromethane up to tetrachloromethane. But simply, They are saying excess. That means methane is the one that is in excess. So it means in the mechanism we shall have more of chlorine, of methane dominating. So it means that this UV light will help us to dissociate, to break down these chlorine bonds, such that we form the two chlorine radicals. Those chlorine radicals, they will come in contact with our chlorine, our methane here. So I can arrange it as this. Then one chloro radical, such that these are, so this one can help us to yield. So it will form a methyl radical. Then plus this one takes this hydrogen, form the hydrogen chloride, which may happen as a gas. Then also this methyl radical, it reacts with the chlorine radical, such that we obtain, that is our one chloromethane, and it is the only one compound that we are going to form. It can be not called one, it is simply, it is added to one carbon atom which is existing in a molecule. It is called chloromethane. So this is simply chloromethane, and that is a product that is required, and it is obtained for as a mitigation, as a chemical plant use. Then that is, I think, most of the work, most of the chemistry where it is. So they are saying the management is reacted. No, the management is interested in the stability of EC products for their applications. Analysis of EC mitigation reactions with equations and an evaluation of EC synthetic pathways and the possible electric impactions of EC products. So since this one, they are just telling us to elaborate more on the stability of these products for the application. Now this the compounds formed that are obtained this one. So they are telling us to the stability of these products for their applications. How are they suitable to be applied in the environment, to be applied in our daily life? If you look at this compound, that is one propanol. It can be used in very well in the daily life, and also chloromethane. So they are telling us we have given the equations, the evaluation of EC synthetic pathways. Now the first part we talked about the synthetic pathways. So it means that now we are talking about the evaluation. So we saw our processes, our ways, our pathways were simpler and not many. So it means that they can be easily applied to obtain the products, and they are inexpensive. If you can look at the products and the compounds, for example, methane, the products. Now we are dealing with gases and some toxic liquids. So it means that during production, safety must be ensured such that no one is harmed. So chloromethane, we can look at a way you can mitigate it. We can mitigate it because now chloromethane, if you inhale it, it can cause some chronic diseases which may lead to death and irritation from these allergic due to allergic conditions with these products. For example, 1-bromo, propan-2-ol. Then also the compounds, they should be used in their restricted areas. For example, if it is a ethyl, for example, they talk about nail use of nail polish removers. That is, for example, polyethylene. It should be used for nails, removing the polish from there, so it's not expected to be put in eyes. So it may cause some irritation. So that was item 5. In other words, and I think we can stop from there. And I think you have obtained something from the discussion. Thank you very much.